A single number keeps atoms from imploding and galaxies from shredding. It isn't luck, it's physics setting hard limits everywhere. The immediate takeaway is simple. Limits create stability, not fragility. From your coffee mug to galaxy clusters, constraints hold shapes together. Each one blocks a runaway effect before it spirals apart. They cap speeds, lock energies, and stop matter from cheating. Once you see them, the universe feels surprisingly sturdy. So, here's how reality keeps itself from ripping apart. Stars wheel across a cold sky, while galaxies keep steady spins. In that calm motion hides a rule that never blinks. Symmetry in time and space guarantees conserved quantities by design. That means energy, momentum, and angular momentum stay book-kept, not lost. If those pillars drifted, structures would shear, heat, and fly apart. Time symmetry means energy accounting always closes without mysterious leaks. Slide a system without changing physics, and momentum must stay constant. Rotate a system without change, and angular momentum remains fixed. Rule of thumb, stable patterns ride on conserved quantities like rails. Push a skater and twisting arms pulls speed into a circle. Pull arms inward, speed rises because angular momentum stays the same. Andromeda's disk spins near 250 kilometers per second for eons. Collisions shuffle energy and momentum between stars, but totals hold steady. Even Earth whispers this rule. After massive quakes adjust rotation. The 2004 Sumatra quake shortened days by 1.7 milliseconds. Noether's insight turns elegance into enforcement, linking symmetry to accounting. With those accounts balanced, orbits persist, disks endure, and bars hold. Without them, motion would unspool into chaos within moments. Bottom line, symmetry welds conservation, and conservation welds cosmic structure together. A lighthouse beam slices darkness but never outruns its own glow. There is a universal speed limit, and nothing material beats it. That limit is light speed, setting causality's fence around every event. This matters because without a fence, causes could scramble effects. Light cones sort possible futures from forbidden ones at every point. Inside the cone, signals can arrive, coordinate, and build structure. Outside it, influence can't reach, so chaos fails to spread. Frames disagree on timing, yet agree on cause before effect. Lorentz symmetry enforces the math, turning time and space into partners. Tiny test, GPS only works after relativity fixes timing drift. Those satellites gain about 38 microseconds per day from relativity. Engineers subtract it, or your map jumps whole city blocks. On cosmic scales, horizons mark how far coordination can travel. The observable radius is about 46 billion light-years today. Galaxies beyond that sphere are real, but forever uncoordinated. Causality keeps neighboring matter in step while isolating the unreachable. Energy cannot bolt faster than information because information rides fields. Net result, a cosmic speed limit keeps order stitched locally tight. Picture a crowded dance floor where no two partners share steps. Matter's stability comes from a simple rule with serious muscle. Fermions refuse to share identical quantum states by Pauli exclusion. That refusal builds degeneracy pressure, which resists compression without heat. Care about this because otherwise electrons would pile into nuclei. Then atoms would collapse, chemistry would vanish, and solids would crumble. Mechanically, stacking fermions forces them into faster, higher energy states. Squeeze harder, the momentum spread widens and pressure climbs steeply. This pressure is cold, born from quantum identity rather than temperature. Example in real terms, white dwarfs are held up by electrons. Pack a sun's mass into Earth size and stop there. Near 1.4 solar masses, electrons can no longer carry the load. That's the Chandrasekhar limit, where collapse demands a new support. Push beyond it, neutrons take over, building a neutron star. Those hold until around 2 solar masses before gravity wins. Numbers vary by rotation and composition, but the ceiling is firm. Everyday matter borrows that same principle, just at gentler densities. So your chair survives compression long before it squeals or shatters. What to remember: identity rules create pressure, and pressure preserves form. A nucleus is a tiny storm, fierce but tightly confined. Its glue is the strong force, binding protons and neutrons together. That glue works at femtometer ranges, then it fades abruptly away. This limit matters because it caps how nuclei can grow. The binding curve peaks near iron, around 8.8 MeV per nucleon. Past that peak, fusing heavier elements costs energy instead of paying. Mechanically, the strong force saturates, so each nucleon has limited neighbors. Add too many, edges fray, and decays restore tighter packing. Beta decays and alpha shedding slide nuclei toward the valley's floor. In stars, proton chains and carbon cycles climb the curve efficiently, but reactors pushing past iron need neutron floods, or extra energy. The sun turns about 600 million tons of hydrogen every second. It gains energy while moving upward on the binding curve. Supernovae forge heavy elements only by borrowing explosive gravitational energy. Uranium hangs high, unstable, with half-lives in hundreds of millions. Those decays heat planets, drive geology, and slowly ease excess mass. So the picture is, strong glue binds tightly, then wisely lets go. Gas falls inward, heats up, and sometimes stops before forming stars. That stopping line has a name you can visualize. The gene's length marks the smallest scale that can gravitationally collapse. It matters because, without it, everything would clump into one lump. Gravity fights pressure, turbulence, magnetic fields, and angular momentum within clouds. If gravity overwhelms support on a scale, collapse runs and wins. If supports dominate, the patch puffs back out, dispersing gently. Virial balance appears when twice the kinetic energy matches binding energy. Then systems settle, trading chaos for long-lived orbits and supported shapes. Rule of thumb, real galaxies live near virial equilibrium for ages. The Milky Way's virial mass is about 1 trillion suns. Its halo's reach spans a few 100,000 light-years. Around it, the local group stretches roughly 3 million light-years. Despite cosmic expansion, those scales are bound, sheltered from the flow. Beyond them, expansion wins, gently prying structures from larger structures. Cluster turnarounds sit near several megaparsecs, where gravity finally yields ground. Numbers shift with dark matter profile, temperature, and internal motions. Bottom line, collapse happens only where gravity beats every competing support. A black horizon hangs like a velvet border around furious light. That border is the event horizon, a one-way membrane in spacetime. It matters because horizons bottle extremes, keeping exterior physics legible. Across the boundary, trajectories only point inward, never back to us. General relativity shapes trapped surfaces, guiding the future toward the center. Cosmic censorship proposes singularities stay hidden, guarded by their own horizons. The area of horizons tends to grow when black holes merge. Hawking showed classical areas enlarge, barring exotic matter with strange pressures. Accretion flows release energy efficiently, near 10% of rest mass. That beats nuclear burning, but still runs under gravity's tight accounting. Sagittarius A weighs around 4 million suns, quiet but persuasive. Even then, its brightness obeys a limit called Eddington. Push harder, radiation pressure chokes inflow, until balance reappears. LIGO's mergers showed final areas larger than initial horizons combined. Those waveforms matched relativity within a few percent, cold and clean. One sentence recap: horizons corral chaos, so outside worlds stay calculable. A warm breeze spreads scent, yet never unmixes it spontaneously. That directionality is entropy, tilting time toward more possible configurations. It matters because gradients drive engines, weather, stars, and even life. Increase entropy overall, while locally you can build sharp order. Do work, export waste heat, and structures can sharpen for years. Landauer taught that erasing 1 bit costs kT times log 2. At room temperature, that's about 3 times 10 to the power of minus 21 joules per bit. You can't compute or reorganize for free, because heat must leave. Bekenstein bounded information inside a region by its surface area. Black holes push that bound, storing about 10 to the power of 77 bits per sun. The cosmic microwave background holds a floor near 2.7 kelvins everywhere. That floor sets noise limits on measurement, memory, and coherence. Engineers respect these numbers, designing sensors, computers, and error budgets. Galaxies respect them too, radiating gravitational energy as they virialize. Tiny test, cooling gas emits lines, then stabilizes near a balance. Net result, entropy allows structure by taxing every rearrangement with heat. The same sky that threatened chaos now reads like a rulebook. Limits turned out to be braces, not chains, holding forms together. Symmetry tied books, light speed fenced causes, and identity created pressure. Strong glue bound nuclei wisely, then handed work to gravity. Horizons sealed extremes, while entropy kept engineering honest about waste. Put together, these limits stop small things and big things from tearing. They give the universe room to change without shattering itself. If that clicked for you, share this with one curious friend. It helps more minds see how order survives in deep space. And if you want more cosmic clarity, tap subscribe gently. Thanks for hanging out under the stars where limits make beauty.